The agricultural market for biological fungi is, expected to double by 2030.
Right, yeah, it's a massive boom.
It is, but right now, thousands of growers are pouring these microscopic treatments into their soil that will just completely fail within 14 days. So today, our mission for this deep dive is to figure out why.
And we're doing that by looking at the science behind a biostimulant called Trykosist.
Exactly, which is powered by the fungus Trichoderma harzianum.
The thing is, we tend to view these biological products like traditional chemicals. Like people just read the species name on the label
Yeah.
and expect uniform results.
They see Trichoderma and think they're good to go.
Exactly. But with living soil solutions, the species name is really only half the story.
So it's kind of like if I'm buying generic Trichoderma, it's like drafting a random athlete for a basketball team without checking their actual sport.
That's a great way to look at it, yeah.
Yeah. Like, I might desperately need a point guard, but I just drafted a golfer. Sure, they're both athletes, the same species, but their specific skill set is totally different.
And in this context, that specific skill set is the strain. In practice, the strain is what makes or breaks the crop.
Wow. Okay, so how does that play out in the soil?
Well, take root colonization. The root zone, the rhizosphere, is this fiercely competitive battleground. And, you have specific strains of this fungus that can completely colonize that zone in like 24 to 72 hours.
While others take, what, a couple of weeks?
Yeah, up to 14 days. Or honestly, they just fail entirely in field conditions. And it's not even just about speed either.
Wait, really? What else is there?
So some strains persist in the soil for 6 to 12 months, actively working, while others just vanish in a few weeks.
So if you're listening to this and thinking, I've tried biologicals before and they didn't work, well, this strain difference is exactly why.
It really is the deciding factor.
Which brings us to the specific strain in Trykosist, right? It's called VBJ16-1.
Right, which was actually isolated in South Africa back in 2004.
And looking at its survival strategy, it seems to rely on being incredibly fast. But how is it actually dominating that root zone so quickly?
Well, it rapidly extends its microscopic threads, the hyphae, through the soil.
Okay, so it just spreads out super fast.
Exactly. By growing so aggressively, it physically monopolizes the space. It snatches up all the resources, like the sugars and amino acids, that the plant roots exude.
So it gets there before any competing indigenous microbes even have a chance to set up shop.
You got it.
But, speed doesn't guarantee survival if, say, a drought hits mid-season.
Right, and that's where its biological structure really comes in. VBJ16-1 produces these specific survival structures called chlamydospores.
Which are what, exactly? Like a seed?
Kind of. Think of a chlamydospore as a microscopic armored bunker.
An armored bunker. I like that.
Yeah, so when environmental stress hits, like intense heat or nutrient deficiency, the fungus retreats into this thick-walled bunker. It essentially hibernates safely until the water returns or conditions improve.
So it can survive much longer than ordinary strains.
Exactly.
But wait, let me push back on something here. You mentioned the strain evolved in South Africa under extreme local conditions, intense heat, drought, very specific soil pH.
Right, very harsh environments.
Yeah, so if a farmer takes this native South African strain and uses it in a wet, cold climate, won't it just go into biological shock? Like, how does it survive outside its native environment?
It's a fair question, but the reality is actually the complete opposite.
Oh, really? How so?
Because it evolved in such an unforgiving environment, its baseline tolerance for stress is abnormally high. So pampered, lab-grown, or imported strains often go into shock when hitting harsh, real-world soils.
Because they're used to perfect conditions.
Exactly. But this native strain is already adapted to extremes. Normal agricultural stressors just don't phase it. It doesn't just survive, it thrives and actually outcompetes the locals.
Okay, so the toughness really translates. And because this fast-acting, tough strain essentially acts as a universal support system for the root zone, I'm guessing it's not just a one-trick pony for a single type of plant.
Oh, definitely not. The sheer volume of crops registered for this product proves that. We're talking cereals, grains, vegetables, oilseeds, tree crops, pulses.
Wow, so pretty much everything.
Yeah, the list is massive, and it fits right into both commercial farming and organic systems, too.
Right, seeing as its series certified for organic use.
Exactly.
We see a ton of trial results in our sources showing things like better grape canopies or larger potatoes, but honestly, getting hung up on the specific yield numbers per crop almost misses the point, doesn't it?
It really does. The real focus should just be the underlying mechanism.
Right, because it's about the roots.
Exactly. When you introduce a highly resilient strain like VBJ16-1, it universally improves how any plant manages stress and accesses food and water.
So the biological mechanism of a healthy, fully colonized root zone is entirely crop agnostic.
Spot on.
The right strain secures that early root colonization and just persists through the tough conditions. To go back to our analogy earlier, the species gets you into the stadium, but picking the right strain is actually putting the star athlete on the court.
And that, makes all the difference for the harvest.
It really does. And, well, it leaves you with a truly provocative question to ponder.
Oh, what's that?
If a locally adapted fungal strain is this much more resilient simply because it was forced to evolve in harsh native soils, I mean, how many other untapped, ultra-tough microbial solutions are just waiting to be discovered right under our feet in the world's most extreme environments?